Okay, hello everyone. So today we are going to start with where we left off. We left off at the return function. So last time we stopped here. So today we begin from here. Okay, so all the previous presented functions have some kind of effect. They produce some text and send it to the console. So all the functions that we have done have been producing outputs. They have been printing lines, they have been printing numbers. Of course, functions like their mathematical siblings may have results. To get a function to return a value, but not only for this purpose, use the return instruction. So if you want a function to return a value, you use this keyword called return. This word gives you a full picture of its capabilities. Note, it's a Python keyword. So this word just does what its name states. It returns something. Return without an expression. The first consists of the keyword itself without anything following it. When used inside a function, it causes the immediate termination of the function execution and an instance return to the point of invocation. So when this return keyword is used inside a function, it causes the function to terminate, to end its execution. Note, if a function is not intended to produce a result using the return instruction, using the return instruction is not obligatory. So if your function does not produce any result, it's not a must to use the return function. We have said one, the return function is used to return a value. And anytime the return function is executed, the execution of the function stops. Sorry, anytime the return keyword, not function, anytime the return keyword is executed, the execution of the function stops and then it gives an output. And then we have said it is not a must for you to use the return keyword if the function doesn't return anything. Anyway, you can use it to terminate a function's activities on demand before control reaches the function's last line. So it is used to terminate a function's activity. We have said that. So consider this function. Define Happy New Year. Wishes is equals to print 3, 2, 1. If not wishes, return. Print Happy New Year. So this function is used to print Happy New Year. It is used to count 3 to 1 if the wishes are true. If wishes is false here, it will stop the execution of this function and then it will print Happy New Year. When invoked without any arguments, it prints 3, 2, 1 and then Happy New Year. If you provide the false argument, this will modify the function's behavior. The return instruction will cause the termination of the function wishes just before it is updated. So if you now here, for example, here, you write wishes is equals to false instead of true, it will print this and then it will terminate here. It won't print this, sorry. Yes, it will terminate here. It will print this and then terminate here. When it is where it is written return, that is where the function execution will end. But if it is true, it will print everything. I hope that is clear. Return with an expression. The second return variant is extended with an expression. For example, here define function and then return expression. So the first return we have seen, you can use the return keyword without an expression. Here, we use the return keyword with an expression. There are two consequences of using it like this. It causes the immediate termination of the function's execution. So if you use the return keyword, it causes the termination of the function's execution. This we know. And then moreover, the function will evaluate the expression's value and will return it as the function result. So whatever expression the return keyword is given, that is what it will return. For example, here, define boring function and then return 1, 2, 3. X is equals to boring function. The boring function has returned its result. Its result is X. If you run this, it will return 1, 2, 3. Like here, as you can see, it has given us the output. The boring function has returned its result. Its result is 1, 2, 3. Because the 1, 2, 3 is the expression given after the return keyword, as shown here. Snippets, write the following text. Okay, yes, we have done this. Let's investigate it for a while. Let's analyze. So here we have defined the boring function, and then we have given it the expression 1, 2, 3 to return. So the return instruction enriched with the expression transports the expression value to the place where the function has been invoked. So the return instruction, when enriched with the expression, it transports the expression value to the place where the function has been called. So here we have seen, we have given the return value, the expression 1, 2, 3, and then we have invoked the boring function here at X. So it will transport this 1, 2, 3 value to this boring function when it runs. The result may be freely used here to be assigned to a variable. Like here, the result has been assigned to a variable X. Note, we are not going to be too polite here. The function, okay, it may also be completely ignored and lost without a trace. That is another thing. The expression may also be completely ignored and lost without a trace. Note, we're not going to be polite here. The function returns a value and we ignore it. We don't use it anyway, like here now. This is an example of how the expression may be lost. Like here, define boring function, print bottom mode on, and then return 1, 2, 3. And then print this lesson is interesting, print boring, and then you call the boring function here. And then this lesson is boring. This is what it returns. When you run that function, it will print this. This is what will be printed. This lesson is interesting, and then this print, the bottom mode on is printed, and then this lesson is boring. Is it punishable? Not at all. The only disadvantage is that the result has been irreversibly lost. So we have seen that sometimes the expressions that are given to the return keyword can be lost. Don't forget, you are always allowed to ignore the function's result and be satisfied with the function's effect. If a function is intended to return a useful result, it may contain the second variant of the return instruction. So if a function is intended to return a useful result, like here, it must contain the second variant of the return instruction. So if you are giving your function a useful result, it must contain the second variant of the return instruction. Wait, what does this mean? Does this mean they are useless results too? Yes. So sometimes there is, okay, let's just move on. We'll meet it at the next page. Yes. There is this none keyword. We can say this is a useless result. It doesn't return anything at all. Its data doesn't represent any reasonable value. Actually, it's not a value at all. Hence, it must not take part in any expressions. Like, for example, here, print none plus 2, it will give you an error because none doesn't return anything. It doesn't contain anything. It's a value. It has no value. For example, when we say none was given. We know nothing has been given. Let's try and run this and see. As you can see, it has given us an error, a type error, unsupported operands for none type and int. So you can't add none type and int. None is a keyword. There are only two circumstances when you can use none. That is one, when you assign it to a variable. For example, here, when we say x is equals to none, this is okay. This is one use of the none keyword. And then two, when you compare it with a variable to diagnose the internal state, when you compare it with a variable, for example, y is equals to 1. And then you come here, y. This is comparing it to a variable. Print y, let's see if it will give us an error or it will run. I have never done this, so let's try and see. Sorry, yes. So, wait, x is equals to, let's run this and see if it will give us an error. It has given us false. So this is how you can use the none keyword. We have said one, when you assign it to a variable, two, you can use it to compare. Like here, we have used it to compare if y is equal to none. We can also run this function. So yes, we can also run this loop, sorry, not function, and see. As you can see here, value is equals to none. If value is none, print, sorry, you don't carry any value. It has run our function, it has run our loop and printed, sorry, you don't carry any value, as you can see. Don't forget, if a function doesn't return a certain value using the return expression clause, it is assumed that it implicitly returns none. So if the return function is empty or the return keyword has not been given any expression, we can assume that it returns none. It returns nothing, in short. We can run this and see. Take a look at the code. It's obvious that strength functions returns true when its argument is even. What does it return otherwise? So what if the argument is not even? Let's print and see. Okay, let's try it and see. Let's try first and see if it will return true if it's given an even argument. Let's give it 6. As you can see, it has returned true. What if we give it 7? Let's see what it will return. It has returned 9. So this is another use case of none. Okay, let's move on. Effects and results, lists and functions. Okay. There are two questions that must be answered. The first is, may a list be sent to a function as an argument? Can you send a list to a function as an argument? The second is, of course it may. Okay, sorry. The answer is, of course it may. You can send a list to a function as an argument. Any entity recognizable by Python can play the role of a function argument. So anything that a Python recognizes, like a list, a dictionary, tuple, a variable, anything that Python recognizes, any entity that is recognized by Python, it can play a role of a function argument, although it has to be assured that the function is able to cope with it. So if you pass a list to a function, the function has to handle it like a list. For example, here, define list sum list s is equals to 0. For element in list, s plus is equal to element, return s. So this function, what this function does, it first defines list sum. So it adds elements in a list, and then it has parameter list, and then s is equal to 0. So it assigns variable s 0. And then for element in list, s plus is equal to element, return s. So that is what it does. You give it a list, and then the elements in list, and then you add s is plus is equal to that element, return s. Now let us invoke it. Let us invoke it and see what it does. As you have seen, we have passed a list. It's supposed to add 5 plus 4 plus 3, which will be 12. As you can see, it has given us an output of 12. If you run it like this, it will give you an error, because we have given it a list value. So if you just give it one variable, it will give you an error. As you can see, it has given us an error. It's a type error. It is telling us int object is not iterable. We have iterated the elements in a list here, so you can't give it just one element. This is caused by the fact that a single integer value must not be iterated through by the for loop. So you cannot iterate one value. You must have several values for you to iterate. So let's try, yes. And here we can't pass two values because we have only defined one variable. Let's run, we have only defined one parameter here. Let's run and see. As you can see, it has given us an error because we have passed two parameters, and here it is only one parameter. So when you get loops like this, just know it's a list. It may be a tuple or a dictionary, but as long as it's something you can iterate through. Okay, effects and results. List and functions continued. The second question is, may a list be a function result? Can a list be a function result? Yes, of course. Any entity recognizable by Python can be a function result. So can you give a list as a function result? Let's check this here. Define strange list fun n. Strange list is an empty list, as you can see here. For I in range 0 n, strange list dot insert 0 I. So this defines a function and assigns a variable an empty list. And then here we loop through 0 to range n. That the n is the parameter we are going to give with the parameter we are going to pass as we invoke the function. We loop through it, and then strange list dot insert 0 I. So you will insert here, you just insert the values of I in the list, and then we return the strange list. We return this list. Let's run and see. As you can see, it has given us 4, 3, 2, 1, 0. We have given it 5. Yeah, let's see. So these are labs. You will do them yourself. I won't do your labs for you. You have to practice. And I also want you to know these labs are very important because when you do the certification, you will get some questions that you must code. So don't just see these labs and think that they are useless, because if you don't code these labs, how else do you expect to code those questions in the certification? You must code and give an output, and you must also, there are some questions which have given you an output and you're supposed to write a code that produces that output. So it's up to you now to do these labs and practice and know. So what are the key takeaways so far? You can use the return keyword to tell a function to return some value. We have known that. The result of a function can easily be assigned to a variable. We have seen we assigned x, the return value, the value returned by the return keyword. Okay. So these are exercises. Let's do them. What is the output of the following snippet? Define hi. Return print hi. When you run this, what do you think it will do? It will return nothing, because when this function is executed, it stops its execution here. So it won't print hi. As you can see, it has returned nothing. What is the output of the following code snippet? Define is int data. If int data is equals to int, if type data is equals to int, return true. And if type data is equals to float, return false. So here, print is int 5. So it will return true. Here, it will return false. And then here, it will return none. As you can see, it has printed true, false, none. So the first one is an integer, it will return true. The second one is a float, it will return false. The third one is a string, and it has not been given what to do if it returns a string, so it will return none. If the data type is a string, so it will return none. What is the output of the following snippet? Define even number list run. List, this is an empty list. For number in range run, if number is even, list.append number. Return list. Even num list. What do you think will be the output of this code? It has returned a list of even numbers, as you can see. So it takes the numbers from 0 to 11, but now it stops at 10. So go do this, go try this last exercise on your own. Okay, functions and scopes. The scope of a name is the part of a code where the name is properly recognizable. So the scope of a name is the part of a code where the name is properly recognized. For example, here x is equals to 1, 2, 3. This x, its scope is inside this function, define scope test. If you use it outside this function, it won't be recognized. So for example, the scope of a function's parameter is the function itself. The parameter is inaccessible outside the function. So if here we had a parameter like y, you can't access y outside this function. It will only be accessible when you call this function. That is what scope means. When we run this, the program will fail to run. The error message will read, name x is not defined. This is because you're trying to access x outside the function. So this is the scope of x only ends inside that function. You can see it has given us an error telling us the name x is not defined. So let's start by checking whether or not a variable is created outside any function is visible inside the function. In other words, can you create a variable outside a function and use it inside another function? So, do I know variable 1? Here, you can see we have created this variable, this var variable outside the function. It's not inside the function, but we are trying to use it inside our function here. Will this be accessible or will it give us an error? Let us run it and see. Yes, as you can see, it has been accessed. We have invoked the function here, my function, and then we have printed it. Do I know variable var? Yeah, it has printed 1. Do I know variable 1? The answer is a variable existing outside a function has a scope inside the function's body. So a variable existing outside a function can be accessed inside the function body. This rule has a very important exception. Let's find out. So let's run this code and see. What will be the result? So here, when a function is defined, when a variable is defined inside a function like this here, var, the function will take the value of the variable inside the function, even if another variable with the same name is defined outside the function. As you can see here, do I know variable 2? And then when you have printed var, it has given us 1. So that's what happens. The var variable created inside the function is not the same as when the var variable is defined outside the function. It seems that there are two different variables of the same name. Moreover, the function's variable shadows the variable coming from the outside world. So here, as we have said, the function will use the variable defined inside it. It will not use the variable defined outside it. Like this here. It has given us 2, so it has used the variable defined inside it. A variable existing outside a function has a scope inside the function's bodies, excluding those of them which define a variable of the same name inside the function. This statement that just explains what I have said. The variable will take the value of the variable inside the function, not outside the function. It also means that the scope of a variable existing outside the function is supported only when getting its value. Assigning a value forces the creation of the function's own variable. So this one also means that the scope of a variable existing outside the function is supported only when getting its value. So this variable was supported only when we wanted to get the value of this variable. That is what this statement means. Assigning a value forces the creation of the function's own variable. So when we assign a value here, let's comment this. So when we assign a variable here, it will create the function's own variable. So it will create a variable called var1 here. because here we have assigned the variable var a value 1. I hope that is clear. Okay, let's move on. Functions and scopes, the global keyword. So okay, hopefully you should. So right now we are supposed to be asking ourselves, does this mean that a function is not able to modify a variable defined outside it? Fortunately, the answer is no. There is a special Python method which can extend a variable scope in a way which includes functions bodies. Such an effect is caused by a keyword named global. So this global function, this global variable can be accessed anywhere inside or outside the function. As we saw when we began scope, we saw that a variable defined inside a function cannot be accessed outside a function. But now when you use this global keyword before the variable name, you can access this variable outside the function. In other words, this name is global. It has a global scope, and it doesn't matter whether it's the subject of read or assign. Let's run this and see what it does. As you can see here, this global variable var has overwritten this one here. Define my function and then global var. So we are telling Python that this var function, this val variable is a global, it is global, it can be accessed even outside the scope of the function. Now here we assigned var the value 2. And then do I know that variable var? When we run this, it will override this var here and it will give us 2, as shown here. Okay. How the function interacts with its arguments. The code in the editor should teach you something. As you can see, the function changes the value of its parameter. It does the change affect the argument. Like here, define my function n. Let's first try to understand this function. Define my function n, print, I got n, and then n is equals to n plus 1, and then print I have n. And then here, var is equals to 1. So we have assigned var the value 1, and then my function, we have replaced n with var, and then print var. Let us run this and see what will be the output. As you can see, this is the output that it gives us. I have got 1. That is because here we have printed print n. We have printed I got n, so we print 1. And then here we add n, which is 1 plus 1, and then print I have n, so we have 2. This is what this means. Conclusion, changing the parameters value doesn't propagate outside the function. So here we have changed the value of the parameter inside the function. But now when we print var outside the function, the value is still 1. I hope you also notice this. The value is still 1. But now inside the function, the value of var has changed from 1 to 2. You can see it has changed from 1 to 2, but the value of var outside the function is still constant. It hasn't changed. This also means that a function receives the argument's value, not the argument itself. So this means that when you pass a variable as a parameter in a function, it receives the value. It doesn't receive the variable itself. Okay, let us try to run this example here. Let me clean that first. Okay, let's try to understand this function. Define my function, my list 1, print my list 1, print my list 2. My list 1 is equals to 0, 1. Print my list 3, my list 1. Print my list 4, my list 2. Okay, and here we have assigned my list to the value 2 and 3. Okay, my function is equals to my list 2. So what will this return? As you can see here, when we invoke this function, print, okay, when we invoke this function, it will print 2 and 3, 2 and 3, because we have invoked it with my list 2. And my list 2, we have assigned it the value 2 and 3, as shown. And here we have assigned the value of my list 2, 2 and 3. And then print 3, my list 1. So it will print this, my list 1 is 0 and 1. And then here print my list 2. So it will print the value of my list 2. I hope you understand what I mean. Here, the reason why this is printing 0 and 1 on the second my list 1 calling, and then here it doesn't print the my list 1 is because here we had not assigned a value to my list 1. So it will take the value in the variable my list 2, because when you invoke the function, we call my list 2. But now when it runs, it finds my list, it takes the value of my list 2 here, and also takes the value of my list 2 here. But now, after it has been run, after we have run these 2 lines of code, it finds my list 1 here has been assigned a value of 0 and 1. So it can now, when we now print my list 1, it takes the value of my list 1. As we said in the previous section, that if a variable is defined inside the function will take the value of the variable. So here it takes the value of the variable my list 1 and prints it here, prints it out here, my list 1. And then here prints my list 2. It also prints the value of my list 2, 2 and 3. So yes, that is what this function basically does. Okay. Now I want you to run this code on your own. This final example here, you will do it on your own. It's just the same as the one we have done it, but the one we have done, it's just the same as this, but it has been tweaked a little bit. So I want you to run it and try and understand it. If you find any issues understanding it, you can reach out and I will help you understand this function. But it's just the same thing we have done, but it has been tweaked a little bit. So let's move on. So key takeaways. A variable that exists outside a function has a scope inside the function's body. we have said that if you create a variable outside a function and you call it inside a function, the variable will be created also inside a function. Sorry. Sorry about that. Like here, we have assigned var outside a function, but when you run it, the variable has been called inside the function. So the variable var is also created inside the function. And here the answer will be 14. It will output 14. Here we have also called the variable, we have assigned the variable var the value 5. When you run return x times var, it will give you 35. That is 7 times 5, which is 35. We have also done this and said if a variable contains, if one variable contains two values, one inside the function and another one outside the function will use the value of the variable inside the function. Like here, instead of using 3, which is outside the function, it will use 7, which is inside the function. And the answer will be 49. X is 7, variable is 7. So, yeah, a variable that exists inside a function has a scope inside the function's body. Example 4, define adding x. Variable is equals to 7. Return x plus var, which will be, when you invoke that function, it will be 7 plus 4, which is 11. But if you try to print the value of the variable var, it will give you an error. It will tell you that that variable hasn't been defined inside a function, has not been defined. So that means the scope of the variables defined inside the function only exist inside the function. They don't exist outside the function. You can use the global keyword if you want to access the variable you have defined inside the function outside the function. We have said that this is an example of that. Yes, what will happen when you try to run the following code? Let us do the first and the second exercises. You will do the rest. What will happen when you try to run the following code? Define message. Alt is equals to 1. Print hello world. Print alt. If you run this function, it will give you an error because alt has not been defined outside the function. It has been defined inside the function. Yes, it has given us a name error. Exercise 2. What will be the output of the following code snippet? A is equals to 1. Define fun. A is equals to 2. Print A. When you run this, what will be the output? What do you think will be the output? Okay, let's check. So when you invoke the first invocation, here we have invoked the function fun. So it has outputted 2 because that is the value of A inside the function. But now when we print A, it will print 1. That is the value of A outside the function here. So yes, you will do the rest of the exercises 3 and 4 by yourself. Okay, these are examples of some functions. Like this one. This is an example of a function that will evaluate body mass index. To get a which is BMI. To get BMI, it is weight in kilograms divided by height in meters. So here we define a function BMI, which takes parameters weight and height. And then we return weight divided by height squared. You can see here, this is weight divided by height squared. And then print, we invoke the function BMI, giving it a weight of 52.5 and then a height of 1.65. Let us run and see. It has given us a body mass index of 19.2837. Yes. Okay. So this is another function. So here, let's try to explain this function and see. Define BMI, weight, and height. If height is less than 1.0 or height is greater than 2.5, or I want you to note the use of this backslash here. This will tell Python that this statement continues in the next line. This backslash is used to tell Python that this next line, this one here, is a continuation of this line, so that Python doesn't throw an error. Or weight is less than 20 or weight is greater than 200, return none. Okay, return weight divided by height squared. So print BMI we have assigned. So here it checks if height is less than 1 or height is greater than 2.5. So the height is in between 1 and 2.5. And then if weight is less than 20 or weight is greater than 200. Less than 20, greater than 200. I want you to note that this doesn't make sense. This value doesn't make sense because the weight is less. Oh, yes, it makes sense. Sorry, it makes sense because the weight, if weight is less than 20 or weight is greater than 200. So let's say you are 10 kilograms or you are 210 kilograms. And here, if you are less than 1.0, so if you are, let's say, if you have a height of 0.5 or you have a height of 3.0, that is what this function means now. It will return none. If the values fall within the range I have given you, it will return none. Okay. Return weight divided by height power 2. So here we have a weight of 352.5. As you can see here, the weight is greater than 200, and then we have a height of 1.65, which falls within the range. The height is greater than 1, and it is not less than, it is greater than 1, but it is less than 2.5. Let us run and see. It has given us none. Why? Because of this weight. The weight values are greater than 200. So I want you to also go and try and explain this function to yourself and do it and try to see what will be the output of the function. If you have any issues, you can reach out and I will help you. We can try and run this other one and see what it gives us. Can try and explain it and run it and see what it will give us. If foot and inch to meters, foot and inch. So here we have defined our function, foot and inch to meters, and then we give it feet and we give it inch as the parameters. Return feet times 0.3048 plus inch times 0.254. So this is just a function to multiply what we give it in feet times this, and what we give it in inch times this value here, and then we add the variables. So here we pass 1 to the feet and 1 to the inch. So it is 1 times this value and 1 times this value, and then we add the answers. It has given us 0.3302. This is the output. So go and try this other one. It has been tweaked a bit, but it is something that we have covered. So also go and try it and see what will be the output. If you have any issues, you can reach out. I will assist you. Okay. These are just other functions. So define is a triangle, A, B, and C. So here we are trying to check if this is a triangle. If A plus B is less than or equals to C, return false. So that means if line A, if what we get in A and what we get in B, when we add them, if the answer is less than or equals to C, this will be false. If B plus C, the answer is less than or equal to A, it will return false. If C plus A, the answer is less than or equal to B, it will return false. Else, if all these conditions are not met, it will return true. Let us run and see. The first one is true. That is, A is 1, B is 1, and C is 1. So A plus B, 1 plus 1 is equal to 2, which is greater than C. Yeah, C 1 plus 1 is greater than 1. So it will give us true, because 1 plus 1 is equals to 2. The same applies to this. So that is why it has returned true. But here we have assigned 1, and then 3. So here 1 plus 1, A plus B is 2. And 2 is less than 3. So automatically it will return false, and it will stop the execution there. Yes. So we can make this function is just the same as this function. These are just this is just the same function, but written in another way. We can try and run this and prove that it's the same function. It's supposed to return true and false. You can see it has returned true and false. So these two are just the same, but they have been written in different ways. This is a shorter way of writing the function we have just seen. So you can try and explain to yourself this function and also run it and see what will be the output. When you get an issue, you can reach out. I will help you. So I want you to also do this labs. This is just the triangle function. We have done a triangle function, so you can do this on your own. You can try and run this. I am giving you assignments so that you go and repeat this module by yourself and read it also by yourself, because that's the only way you are going to pass this certification. You won't pass it if I keep on doing the functions for you. So go and do all these functions from 4.5 from here. the module is 51%. So from 4.5.1.4, where it is creating functions and testing triangles. Go and do those functions and run those functions and try to understand and explain those functions by yourself. If you meet any issues, you can reach out and I will explain them to you. Yes, so the section summary. Okay, let's do this. Let's do the Fibonacci series first so that we learn about recurring functions. Another function we're about to write are factorials. Do you remember factorials in school? It's marked with an exclamation mark and is equal to the product of all natural numbers from 1 to up to its argument. So this is how a factorial number looks like, a factorial code or a factorial function looks like. We can run and see. This we have defined here, define factorial function n. Yeah, if n, okay, if n is less than 0, return none. If n is less than 2, return 1. Product is equals to 1. For I in range 2, n plus 1, product is equals to times I. So this is just a function here that returns if n is less than 0, it returns none. If n is less than 2, it returns 1. And then here it assigns the product value, the product variable, the value 1. And then for I in range n, in range 2, n plus 1. So I starts counting from 2 to n plus 1. And then here, product times I. Product is equals to product times I, return product. I, okay. For n in range 1 to 6. So here, the value n is in range 1 to 6. So this n is in range 1 to 6. Print n and then factorial function n. So n is 1, its factorial function is 1. If n is 2, its factorial function is 2. If n is 3, its factorial function is 3. If n is 4, its factorial function is 4. If n is 5, its factorial function is 120. So there is something called the Fibonacci series. Go and try and implement this function yourself. It's the same, it uses the same formula that the function we have done uses. Okay. There's one more thing. There's something called recursion. Recursion is something that reoccurs. This term may be used, this term may describe many different concepts, but one of them is especially interesting, the one referred to computer programming. So recursion is where a function invokes itself. Two cases seem to best illustrate recursion in functions: the Fibonacci series that we have done, and then the Fibonacci series, and then the factorials. So we have done the factorials. I have given you the Fibonacci series. This is just the same as this. Okay, it uses the same formula as the factorials. The Fibonacci numbers definition is a clear example of recursion. Okay, so let's try and define this function so that we see. define Fibonacci series n. If n is less than 1, return none. If n is less than 3, return 1. Element 1 is equal to element 2 is equal to 1. So here we have assigned element 1 is equals to element 2, which is equals to 1. The sum is equals to 0 for I in range 3 n plus 1. So for I in this range, it starts at 3 and then it ends at n plus 1. And here we have said that if n is less than 3, we return 1. If n is less than 1, return none. The sum of element 1 plus element 2, we have assigned the variable the sum element 1 plus element 2. And here we have said element 1 comma element 2 is equals to element 2 comma the sum. So here we assign, here I want you to notice one thing. We assign element 1 the value element 2, and then we assign element 2 the value gotten from the sum. I hope you notice that. And then we return the sum. So this is a function that is calling itself. Okay, it's recurring. It's invoking itself. Here, for I in range 3, n plus 1. And then here, the sum is element 1 plus element 2. So the new element, after we add it, the new variable will be stored in the sum, and then we assign the variable that was in element 2 in element 1, and then we assign a variable that was stored, the value stored in the variable the sum to element 2. I hope you understand what I mean. You see what is going on and understand what I mean. If you don't understand, kindly ask your questions or say you haven't understood. I will repeat. And then we return now the sum. And then here for n in range 1 to 10. So here we have said n plus 1. And this n ranges from 1 to 10. So it will, if this is 1, it will be 1 plus 1. If this is 2, it will be 2 plus 1. If this is 3, it will be 3 plus 1, like that. And then print n, Fibonacci series n. So this is an example of a recurring or a recursive function. I want you to go and read deeper into this. This requires a lot of practice. Let us run it and see. This is the output it gives us. Go and also do practice on this Fibonacci series. That is why I have not explained the function before, because you need to practice on this. This requires a lot of practice. It requires a lot of practice. So this is the section summary. A function can call other functions or even itself. And we have said when a function calls itself, we say the function is recurring, and it is called a recursive function. You can use recursive functions in Python to write clear and elegant code and divide it into smaller organized chunks. So this is the usage of recursive function. It is used to write clear and elegant code, and it divides the function into smaller and organized chunks. On the other hand, you need to be careful, as it might be easy to make a mistake and create a function which never terminates. So when you're writing a recursive function, you might make a mistake and create a function that runs forever. It never terminates. You also need to remember that recursive calls consume a lot of memory. So recursive functions consume a lot of memory. So a recursive functions has its advantages and its disadvantages. Okay. So today we are going to end there. We need at least We need to finish this module in the next week. By next week, we should have finished it. So I will do my best to finish it. Yes. So thank you for coming and thank you for listening. I will share the recording. Yes, thank you. If you have a question, kindly ask before I end this call.
I don't have any questions.
Okay. Thank you.